Dear folks, this is the last problem, industrial problem, which we will be discussing. And if we are able to develop a linear programming model, we can use any method, or we can also use the any software, Tora, to solve this linear programming model. So these are the manufacturing problems, challenges with the constraints, with the maximization of profit or the minimization of the cost. Let's begin with the problem. A jewelry store makes necklaces and bracelets from gold and platinum. So they are the two materials, and the necklaces and bracelets are being made. So you see the two things are being made. So since both things are being made with the mixing of gold and platinum, so x and y variables, decision variable has to be justified. The necklace and bracelets, number of necklace and the number of bracelets. So bracelets, you see, we have given with the y, represented with the y, necklaces with the x. Afterwards, the store has 18 ounces of gold and 20 ounces of platinum. So this is the constraint the store has, of the quantity of gold they have. Okay, constraints are there: 18 ounces of gold and 20 ounces of platinum. Constraints are there. Now let's talk about the equation. Whereas each bracelet requires 2 ounces of gold and 4 ounces of platinum. So when we talk about the bracelet, so what does it require? It requires the mixing of 2 ounces of gold and 4 ounces of platinum. Okay, and maximum, we know the quantity is the 18 and 20. So obviously every bracelet and every necklace has to be mixed, but the constraints are given in a distinctively differently. So we will be using three, that is the ounces of gold for a necklace, and this two is the ounces of gold for bracelet. So gold has to be of bracelet, and necklace has to be separate, and it has to be in the addition way. And as we already been given that store has, this is the maximum quantity the store has, so it would be less than and equals to platinum. When we talk about the platinum, 2 ounces of platinum we have for the necklace, and 4 ounces of platinum required for the bracelet, and the total we have the constraint of 20. So it is, we have the total quantity of 20. So all the bracelet and necklaces has to be made the maximum with the maximum, uh, 20 20 ounces of platinum. Okay, let's move. The demand for bracelets is no more than 4. Okay, demand constraint is given, it is no more than 4. Okay, no more than 4 is it can be less than 4, but no more than 4. Okay, a necklace earns 300 in profit and a bracelet $400. So you see, we must get to know the profit maximization function. So the z must be equals to 300x plus 400y. X is for the necklace and y is for the bracelet. So this is the profit function. And you see the non-negativity constant must always be there, because there must be some quantity of bracelet and the necklace. It cannot be less than 0. It must be greater than or maybe equals to 0. The store wants to determine the number of necklaces and bracelets to maximize profit. So if you want to know the number of x and y, you may go for the graphical method, or you may use any software or any other method. Tora can be used as software, or graphical method can also be used. So that will be finding your number of necklaces and number of bracelets. Thank you very much.